Alright, going over the homework that is on page 193, 1 through 4. We're looking at problem number 1. In problem number 1, a 0.5 kilogram football is thrown with a velocity of 15 meters per second to the right. A receiver catches it and brings it to a rest in 0.02 seconds. What is the force exerted on the ball by the receiver? So we're taking this formula right here, and we are trying to find the force. So when we plug in all of our numbers, this is what we get. Force times the time is equal to the final momentum because the ball stops minus the initial momentum because the ball is moving. So you take this and you multiply, and you get 7.5. It's negative 7.5, and you get 0 here, and you get the 0.02 seconds. What you then have to do is you have to divide by 0.02 seconds over to here. Yes, this will give you a negative force. Let me get 1 second and figure out what that force is. And when I did that, I got negative 375 newtons. This is a stopping force, so it's okay for that to come out negative. Looking at number 2. Alright, let's kind of clear this stuff out and look at number 2 here. Number 2, an 82 kilogram man drops from rest on a diving board 3 meters above the water into the water, coming to rest 0.55 seconds after he hits the water. What is the net force on the diver as he is brought to rest? So we have to kind of set this one up a little bit. Let me make some illustrations. So looking at our illustration here, we've got a problem much like the one we did in review last chapter, where a guy jumps off the diving board. And what they tell us is this 82 kilogram guy jumps off the diving board here. He starts with a velocity of 0, and he speeds up until he hits the water with what we would call a final velocity. Well, that's also his initial velocity as he enters the water, where the water then stops him. We're looking for the force supplied by the water that stops him. To solve that, of course, we need to know how fast he was going when he hits the water, the VI I have written here. This VI is the same as this VF when he hits the water. So we have to do the equation where he is falling at a certain speed from that height. That equation is this one. You'll have to excuse my subscripting. VF squared is equal to 2GH. Well, we know that he fell 3 meters. So let's plug in 3 meters in there. 3 meters in. And figure out how fast he was going. You should be calculating this on your own if you don't have it already done. 3 times 9.81 times 2. That's 58.86. Square root that. I have a velocity of 7.67 meters per second as he hits the water. So then, that's the speed he hits the water, so that's the speed he enters the water with. So that becomes our VI up here. So now, this is 0. We multiply these two out. And I got, and then of course, 629 here. So I got a minus 629. That's a 0. I have to divide by the 0.55. And I get an answer of 1,144 newtons. Alright, moving on to number 3 then. In this problem, and actually the next two problems, it is vitally important that you recognize that if things are going opposite directions to one another, you assign them opposite signs of direction. Now, I don't care which way you make which sign. Typically, we read from left to right, so we typically would consider going to the right as a positive. Typically, the way we think, if we're traveling north, we consider that positive, but you don't have to do it that way. You can choose which way you want it to be. You can make to the left positive and to the right negative. I don't care. Okay? Hey, the bird says good morning. Now, so here we are. Looking at it, a 0.4 kilogram soccer ball approaches the player horizontally with a velocity of 18 meters per second to the north. The player strikes it and makes it go the opposite way with 22 meters per second. Was the impulse delivered? Remember, the impulse is each side of this equation is called impulse. This is change in momentum. This is change in momentum. So we're looking for, I'm just going to put a D. I'm not searching for a delta. Delta P. Sorry, I'm not searching for a delta right now. Equals. And then we're going to do MVF minus MVI. So is it 0.4? 0.4 kilograms times, let's see, the final velocity is 22 meters per second. 22 meters per second. And I'm going to make that positive because I want it to be. Minus 0.4 kilograms times, I'm going to make the 18 negative because they're going opposite directions. Negative 18 meters per second. I get to pick that. You can do it the other way if you like. You can make this positive and that negative. I don't care. And your answer will be negative instead of positive. It's really irrelevant at this point. So now it's just a matter of multiplying the stuff out and seeing what you get. When I multiply, if you haven't done this already, you need to be doing it. 0.4 times 22. I got 8.8. 8.8 on this side. Then I'm going to add a positive here. And over here, 0.4 times 18. And over here I got 7.2. And when I add these up, because subtracting a negative is just like adding it, I get a change of 16. 16 kilogram meters per second would be the answer for number 3. So kind of bring that up here. And there. And that leads us to number 4. Number 4 has 2 parts. A half kilogram object is at rest. A 3 Newton force acts on it during 1.5 seconds. What is the velocity after that time? That's part 1. So in this case, they actually give us a force. They give us 3 newtons. They give us the time, 1.5 seconds, is equal to a mass of 0.5 times VF, 0.5 times VF, minus, initially at rest. I'm just putting a 0, I'm taking a shortcut. So then when you multiply this stuff out, you end up with 4.5 here and a half. You divide by the half to get it alone, and 4.5 divided by 0.5, and you're going to get a VF of 9. 9 meters per second. Now, here's where we got to start talking about directions. 9 meters per second to the right, because the force is to the right, it was at rest. So I'm just going to go and do this here. Dot, 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 to the right. Part 2, now we have a force of 4 newtons to the left. This force was to the right, I made it positive. Therefore, I need to make this force negative because it's going the opposite direction. And that is extremely important to the problem. This happens for 3 seconds times 3 seconds equals. Now, we want to know the final velocity. So again, 0.5 kilograms times VF. Minus, in this case, now we have initial velocity because we found it from the problem because the ball is rolling and then we kicked it the other way. So 0.5 kilograms times 9 meters per second. Now it's time to do our math here. 0.5 times 9 is 4.5. 4 times 3 is 12. So 12, 4.5. Type those out here. Negative 12 here. This is going to be negative 4.5 there. Mathematically, mathematically, to move this thing, I have to add it over, right? I have to add that. Do this. I have to add that over. So that gives me 7.5 equals 0.5 kilograms. I'm not writing it, sorry. Times VF. And then I'm going to divide by 0.5 kilograms. Oh, that's still negative. Divide by 0.5. What's 7.5 divided by 0.5 is 15 for your final velocity. Now, folks, because I'm not there to go over this with you, if you have questions, make sure that you ask a friend next to you at some point when you're working on something. I'm sure that someone around you understands and can help you with anything I may have done. All right. Good luck.